Welcome to Practice B. We are getting ready for the state exam, so we're going to try some extended response questions. Let's start with number 35. A company starts to track the number of phone calls it receives each month. The information about the number of phone calls the company received for the first 3 months of tracking is listed below. For the first month, the company received 4,264 phone calls. For the second month, the company received 25% more phone calls than the first month. And then for the third month, the company received 6,396 phone calls. What was the percent of increase in the number of phone calls from the second month here to the third month here? So we're calculating the percent of increase. But we don't actually know how many phone calls were received for that second month. We're going to have to figure out, based on the first month, how much that is. So, let's use a tape diagram. Step 1. Well, this represents the first month. We know they received 4,264 calls that first month. That's 100%. But we also know from the first month to the second month, there was a 25% increase. So let's increase by 25%. This represents the growth. So for the second month, if this is the first month, for the second month, 100% plus 25%, the second month must have been at 125%. We don't want to know the growth. We want to know how many calls were received that second month. So we're going to take our percentage rate and convert it to a decimal. Take 125%, scoop, and make it 1.25. We're going to calculate the number of calls. Here we go. R times T equals P. 1.25 times the total, which is 4,264, equals the part we're looking for. Take a moment and make sure you have all these notes. Pause your video if you need a little bit of time to catch up. When you're ready, punch in 1.25 times 4,264 and hit equals. You should have gotten 5,330 calls for that second month. Now, let's calculate the percent of increase from the second month to the third month. We now know how many calls we received the second month. So let's continue on. Step 3. This is a percent of increase, so we're going to use the ROD formula. We know in the second month, we had 5,330 calls. And the new amount, which is the third month, is 6,396 calls. We need to calculate the difference. So this is our O original, but now we need to subtract to find the D difference, or the growth. Pick up your calculators and take 6,396 and subtract 5,330. We grew by 1,066 calls. That is the D difference. In your final step, you're going to use the ROD formula to calculate the percent of growth. R times O, the original, equals D, the difference. R times the original amount for the second year, 5,330, equals a difference or a change of 1,066. Now solve for R. You're going to divide both sides by 5,330. Punch in this division problem. You should have gotten a rate, a decimal rate of 0.2, and you may add a 0. If you convert it to a percent, which they want a percentage or the rate of change, you get 20%. Let's move on to the next problem, which is much shorter. Problem number 36. It says a car travels 30 1/5 miles in 2/3 of an hour. What is the average rate of speed in miles per hour for the car? In other words, what's the unit rate? We know miles goes on top and hours on the bottom. Put the 30 1/5 on top and the 2/3 on the bottom. We're going to find the unit rate. How many miles per 1 hour? Grab your calculator and use your ABC key to divide. Get down the notes, pause the video if you need to, but punch in 30, ABC 1, ABC 5, divided by 2, ABC 3, and hit equals. You should get 45 3/10 of a mile. As a decimal, you would get 45.3 miles per 1 hour. Now let's move on to the next problem. Problem number 37. Todd ordered pictures from a photographer. Each picture cost $7.50, and then there's a one-time shipping fee of $3.25 that is added to the cost of the order. The total of Todd's order is $85.75. Now here's the key. How many pictures P did Todd order? Well, we can write an equation to solve. We're going to take the variable term plus the constant term, and of course, it equals the total. So let's start with P, the pictures, the variable term. We know there's 750 times every picture. And we know the total of the order is $85.75. And we have a one-time constant shipping fee of $3.25. Drop a dotted line, pause the video, and solve for the number of pictures that Todd ordered. Please pause the video right now. Take away $3.25 from each side, and you get $7.50 times P equals $82.50. And then you divide both sides by $7.50. You should get P equals 11 pictures. Let's move on to the next page, number 38. For number 38, we're making a prediction. Problem 38. A museum employee surveys a random sample of 350 visitors to the museum. Of those visitors, 266 stopped at the gift shop. Based on these results, about how many people out of 2,300 visitors to the museum would be expected to stop at the gift shop? Make a prediction. Let's calculate the rate for the sample that's been studied. Step 1. The probability that they're going to stop at the gift shop for the next shopper can be figured out by taking part over total, or in this case, a total of 350 were surveyed and 266 stopped at the gift shop. Now divide and convert it to a decimal rate. Punch in 266 divided by 350. We get a rate of 0.76, or basically 76% visit the gift shop. So what if we're talking about a larger group of visitors, like 2,300 visitors? Make a prediction. So we draw a tape diagram, and the total is 2,300 visitors. And 76%, or 0.76, should visit the gift shop. Take a moment and draw the tape diagram. If you need to pause the video, please do so and copy down all the notes. Now we need to use our formula to calculate 76% of 2,300. R times T equals P. 0.76 times 2,300 total visitors. Punch it into your calculator. 0.76 times 2,300. You should get 1,748 people would be expected to stop at the gift shop. Let's move on to the next question. Please turn the page. Question 39 states, a candy store sells caramels and milk chocolates by the pound. The table below shows the total cost in dollars for a pound of each type of candy the store sells. The price per pound is here. That is your Y value. And in this case, caramels cost $9.28 per 1 pound. That's the unit rate. And for milk chocolate, it's $12.80 per 1 pound. It states how much more is 1 3/4 pounds of chocolate than the cost of 1 3/4 pounds of caramels. Show your work. We need to multiply to find out how much 1 3/4 pounds cost. Let's start with the milk chocolate. So we're getting 1 3/4 pounds times $12.80. We're going to multiply on the calculator in a moment and calculate that price. For the caramels, we're going to take 1 3/4 pounds times $9.28. They should be cheaper. Take a moment, pause the video, and calculate the total cost of the milk chocolate and the total cost of the caramels. Then we'll subtract to find the difference. Grab your calculator and punch in 1 ABC3 ABC4 times 12.80. You should have gotten $22.40 for the milk chocolate. Now for the caramels, punch in 1 ABC3 ABC4 times $9.28. You should have gotten $16.24 for the caramels. Now punch it into your calculator. Don't do it by hand. We want accurate results. Let's do 2240 take away 1624, and we can find the difference. This completes problem 39. Please flip to the next page. Welcome to problem number 40. On this page, we're given a word problem, and we're asked to write an equation for the information we've been given. And on the lines, we're also asked to explain our work. Just because there are 3 lines doesn't mean you can't extend the lines. Like so, please add 3 or so more lines. And you're going to take those lines and cut it into 2 sections. In this section, you'll show your work, and in the other section, you'll complete the writing. Now let's read our story problem. At the grocery store, the price of a watermelon is determined by how many pounds the watermelon weighs. The price of the watermelon that weighs 7.3 pounds is $4.38. Write an equation that you can use to determine the price P in dollars of any watermelon based on the number of pounds W the watermelon weighs. Explain the process you used to determine the equation. Well, the real information, the numerical information we've been given is here. And that's a ratio. We're going to set up, with money on top, of course, $4.38 per 7.3 pounds. We're going to take that ratio, divide to get a unit rate. Grab your calculator and punch in 4.38 divided by 7.3. We're going to figure out the cost per 1 pound. Punch that in. We get the unit rate 0.6, and 0 makes 60 cents per pound. That is a unit rate. And we know when we get a ratio, such as this, and we can convert it to a unit rate, we're going to be writing an equation that looks like this. K times X equals Y. We know right now that the K rate is 0.60 or 60 cents. So we can write that down here on the lines. We also know that K is equal to Y over X. Or in this case, dollars per pound. But we can't use Y and X. We have to use the letter P for dollars. So wherever there's a Y, we're going to put in the letter P. And wherever there's an X, we're going to use a W right here for the number of pounds. So our official equation is 0.60 times W, each pound, equals P, the price. Now let's begin to write. Start by using the answer in your opening sentence. The equation is 0.60 times W equals P. First, let's talk about how we arrived at a K rate of 0.60. You can say something like this. Since $4.38 over 7.3 equals 60 cents over 1, the unit rate gives us a K value of 0.60. Take a moment and copy that down. And then we'll write the next sentence. Pause the video if you need to. Finally, we can say $4.38 is to 7.3 as Y is to X. Y is the price, P, and X is the pounds, W. This concludes this problem. Take a moment and copy that down. When you're ready, you can move on to the final page. If your final page is done, then your packet is complete. For those of you that need the final page, let's move on and take a look at Omar and Caleb on the last page. Make sure you have all the notes for the rest of the packet. Number 41, Omar and Caleb each had a repair made on their cars. The initial cost of each repair is $1,000. Omar and Caleb have 2 coupons. Each of them used both of his coupons towards the cost of the repair. One is for $80 off the cost, and the other is for 15% off the cost. Caleb and Omar use their coupons differently, as shown below. Omar first uses the $80 coupon, and secondly, he uses the 15% off on the remaining balance. Caleb first uses the 15% off, and then he uses the $80 off on the remaining balance. Who paid the least amount of money for his repairs, and how much less did he pay? So, we have 2 answers we need to provide. When you're doing a comparison problem such as this, let's put Omar on one side and Caleb on the other. Now, Omar had $1,000 worth of repairs done. He decides to use the 80 off first. So simply take and write down $1,000, and on your calculator, subtract $80. He's now down to $920 owed. Then he puts down the second coupon for 15% off. This is going to require a tape diagram. We're going to take $920 and discount it 15%. So step 1 and step 2. If he gets to save 15%, we know out of 100% total, if 15% is saved, he must be paying the other part. Well, he will pay 85%. So finish up this problem by finding out what 85% of $920 is, and that's how much Omar is going to pay. Caleb, on the other hand, takes a different route. Step 1. He is going to use his 15% coupon off on the $1,000 owed. He uses that first. This is what he saves, 15%. That means he's going to pay 85% of $1,000, or at a rate of 0.85. So let's use the formula R times T equals P. And we're going to take 85 hundredths times $1,000. Now you can pause the video at any time and make sure you have all these notes. Caleb ends up paying $850. Step 2, take $850 and subtract the second coupon, which is $80 off. You can finish this problem on your own. Make sure you go back to what they want. Who paid the least amount of money? We need a name. And what's the difference? How much less did he pay? This concludes Packet B.